All right, so your written test number 2 will be tomorrow. Make sure you go to your enroll session only, either the morning or the afternoon. And on Sunday, I held a review session, and I already released the recording and the notes on the lecture site. You can check it out. That might be useful to you. Your lab number 4 is due this Friday, the usual time, the noon time. And I will also release your final lab exercise in time as well after the submission deadline. And lab number 5 will be again about inheritance. So you definitely get another opportunity to really practice. But for your programming test number 3, which I'm going to give you the guide tomorrow, but programming test number 3 is going to cover basically lab number 4. So your safest bet is to study very, very carefully about lab number 4. You can definitely try to do as much as possible on your own before the submission deadline. And once I release a solution and grading test, you can also make use of them to get some feedback for your own solution. All right, you can look forward to it. And for your programming test number 2, and I really released the result and the feedback from yesterday. So you can take a look. If you have any concern about it, feel free to reach out to me. And please, no email. If you want to discuss it, office hour, either Zoom or in person, either way. All right, any questions about the course? Any points you would like me to clarify? All right, if no, let's now talk about recap from last Thursday. All right, so last Thursday we spoke about inheritance, and today, of course, we'll continue with the story, but let's see what should be noticed from last time. All right, so last time we talked about basically without inheritance, the resident students and the non-resident students class, they are separate classes, meaning that you should have separate arrays to really store them, meaning that you have to write separate loops for handling each one of them independently. But once we get to so-called polymorphic array later in the lecture, most likely about 2 or 3 lectures later, in which case we're going to learn about how to greatly simplify this student management system class by using inheritance. That's something we'll talk about a little bit later. But for now, you just got to understand without the inheritance, you have to use so many arrays for the purpose of the storage. And we spoke about the 3 classes using inheritance, and we spoke about 1, 2, 3, 4 different things you may want to do in the subclass. To be honest, just 3. Number 1, you just cannot redeclare any attributes. Any attribute that are not private, they will be inherited. You have no choice. They will be inherited to the subclass. And number 2 here is very important. A subclass can add as many new attributes and methods as you like. What does this mean? The consequence is the expectation that we talk about. So what do we really mean? The expectation for a single class. That means the attributes and methods you can call upon, the objects of that particular type. But if you say a subclass can add new attributes and methods, that means we are increasing the expectation for the subclass. That's a very important insight we're going to develop further today. All right, so pay special attention to number 2 over here about adding expectation. Okay. And number 3, let's say for the inherited methods, if you're happy with them, leave them as is. You don't need to override them. You don't need to. Case number 4, for the inherited methods, let's say you're not happy with them. Let's say get tuition. In the resident student class, you want to somehow, based on the, in addition to the base amount, you want to calculate premium rates as opposed to discount rate, right? There will be different overridden version that you have to watch out for. One more thing to note, which we're going to also show you how it can work when we talk about dynamic binding. At the moment, for these 3 classes, we got 3 versions of the get tuition method. We got version number 1 that's defined in the student class, the parent class. In each of the subclasses, we got another 2 versions of the get tuition. So we got 3 versions in total. Exactly which version that's going to be invoked at the runtime, it really depends on the dynamic type of the objects you're calling the method. All right, that's something you want to watch out for, which I'll develop further. And we talk about how you can visualize the parent versus child objects. What you want to notice would be, so for the parent object student here, you got all the attributes that's declared in the student class. When you talk about some subclass objects here, some like a child objects, for resident students, there are 2 parts you can perceive. Part number one, it will be all the attributes inherited from the parent class. And similarly, for non-resident student, just another subclass, they also inherit all the attributes from the parent class. In addition, each subclass may have some additional unique attributes that you should really include in the visualization. For example, premium rate should be only unique to resident students, and discount rate should be unique to non-resident students. So including the additional attributes into the child object is also very important. Otherwise, when you trace the method, you'll get confused. All right, just remember that. All right, and the next one here, that's about tracing the code. And that one there, you can also refer to an in-lab demo that I did last Wednesday. All the materials are already there. I'll leave that to you. And I talk about various different highlights you really want to pay attention to when you trace the code. All right, I'll leave that part to you. If you got trouble, let me know. And we talk about 4 different cases for the modifiers. So you got either private, protected, public, or no modifier. 4 cases. In the case of the classes, it's pretty simple. Either public or not public. Only 2 possibilities. But when you talk about attributes or methods, there are 4 possibilities. So we went ahead to talk about this table over here. So attributes that may be either public, protected, no modifier, or private, you should really know to what extent it would be visible, either within the current class, within the current package, or within the current projects, right? There are different layers over there. All right, that part there, you can refer to the lecture recording for details. And, okay. Yeah, just remember, private attributes will not be inherited to the subclass, only protected. So this page here is very important. We talk about expectation, right? I'm going to talk about expectation a lot today. Remember, the definition is simple. Expectation is really about, let's say, what will be the expectation for student class? It will be all the attributes and methods that are declared in this particular class. What will be the expectation for resident students? It will be, number one, all the attributes and methods inherited from its parents. Number 2, all the new additional attributes and methods that's declared in resident students. Right? That's exactly this table over here. All right. So you can see the students, resident student, non-resident student. So these are the static types over here. So the static type tells you the expectation list of methods and attributes you can invoke on the class. So here you can see they all share the same. But for the subclass, for example, resident students here, that one there has additional expectation you can have, which will be premium rates and discount rate. Sorry, premium rate and set premium rate, beg your pardon. However, for resident students over here, it's not part of its expectation for discount rate and set discount rate, because these 2 are in the sibling class, which has nothing to do with itself. All right, recap. This class over here is going to inherit all the expectation from the parents, plus additional expectation that's newly declared in the class. Any expectation that has to do with its sibling here, no, it's not included. All right. So this table here is very important to not understand how the expectations are derived and also how we generalize it. The final page that we spoke about was this polymorphism definition. I'll give you the formal definition a little bit later, but for now, getting some intuition is more important. So we spoke about, for example, here, you got S and RS. We talk about whether or not the variable assignment should compile. Whenever we talk about compilation, you only look at static type. Okay? So now, S has a static type, students. RS has a static type, resident students. And we say that if you try to do S is assigned to RS, it will compile. On the other hand, this one over here will not compile. Okay? For this one here, let's now do a quick recap, and then we can move on to another intuition. Okay, I'm going to put it here. All right. So what we have is we got students S, and then whatever on the right-hand side is not relevant for our discussion because we only talk about compilation. Also, we got resident students. and RS. You might do something in between, maybe set the premium rates and etc. And what we talked about was S is assigned to RS. And this variable assignment here is going to compile. All right? What you want to notice is for RS over here, we know that its static type is resident students. On the other hand, for S on the left-hand side over here, its static type is students. And let's now also draw the relevant hierarchy. Let's only put student and resident students. So student over here is the parents. Resident students extends from that. So now let's see. We are basically saying whatever that we can expect from students, which is over here, we can also expect from resident students, because resident student is guaranteed to inherit all the expectation from students, all the attributes and all the methods. So that's why you can do this particular assignments. Whenever you say, for example, s.name, s.courses, etc., is guaranteed to be available in the RS, resident students. On the other hand, if you do RS is assigned to S, as we illustrated last time, it's going to crash. So it should not be allowed. All right, I'll write down what I just said, and then we can move on. The question you want to ask yourself would be, can the static type of the right-hand side fulfill the expectation of the static type of the left-hand side? We're asking whether resident students can fulfill the expectation of students. Yes, we can. All right. That's something I will also show you a little bit more, but that's basically what we said last time to give you the intuition. And this is really the number one rule you're going to need a lot when we talk about compilation, to check the inheritance. All right, any question? Yes. It will give you a compilation error, yes. So let's say given this setup over here, if you try to write RS is assigned to S, okay? If you try this on Eclipse, which I really encourage you to try, it's going to have a red underline over here telling you this variable assignment is not possible. It will say something like this. It will say something like the student class is not a subclass of resident students. It's going to say something like that. So the idea would be the student class over here cannot fulfill the expectation for resident students. For example, resident student may expect a PR, premium rates, which student cannot fulfill. Right? Yeah, it's a very important point to remember. Yes. Okay, typecasting, I would say we delay this topic a little bit later to maybe Thursday. Okay, typecasting. I promise I'll get back there. Yeah, for now, let's say we cannot do any typecasting just yet. Without the typecasting, what's going to work and what's not going to work? Yeah. Yeah, you can use a super keyword. So you can take a look at maybe the get tuition method in the resident student class, in which case we say super.get tuition. That one effectively calls the version of get tuition from the student class. You can definitely do that. Yes. Maybe that answers your question, I hope. Okay, good. Yeah, super keyword. All right, guys, if no other question, I would suggest we are done with the recap and we should move on to the next one, dynamic binding. It goes very closely with polymorphism. And as I said, for now, don't worry too much about the words just yet. I'm just mentioning the words to you, but let's now understand the intuition behind. All right, let's now take a look at the tracing. Let's say we try the first line here. We got a course object, EECS2030. That's a course object, straightforward. And we declare reference variable s with the static type students. So you can think about in the beginning, we got s over here is simply pointing to null in the beginning. And it has the static type students, right? It's the static type. And we're going to set up another two objects. We got rs, we got nrs. rs dynamically is pointing to a resident students objects. So you can think about this guy here, the title of the box is dynamic type. So this will be the dynamic type. Similarly, you can see for NRS, we got non-resident students object here. And that one there is referring to this particular object here. So this is also the dynamic type. Dynamic type. Okay. And we try to do other things. We try to set a premium rate to be 1.25 over here. Set a discount rate to be 0.75. Straightforward. And we also try to register 2030 into for both students. So that one is going to be course over here and also course over here. And by the way, that's aggregation, right? That's also something you're studying for tomorrow, okay? Because we got sharing. All right, so now we want to talk about the final two lines over here, these two lines. And to really understand these two lines completely, let's consider different timings, different execution timings. Okay, I'm going to write it down, and we're going to fill them out together. So let's say this is 1. And let's say this is 2. This is 3. This is 4. You know what? I'll change my mind. How about this one here? I think that'll be even more direct. Number 1, number 2, number 3, number 4. So number 1 is right before we execute this variable assignment. Number 2 is right after. Number 3 is right before we execute this one here. Number 4 is right afterward. We're going to see in these 4 explicit timings what's going to be the dynamic and static types for S. Okay. So I got 1 here, 2 here, 3 here, 4 here. So let's now have these rows over here. And then in the columns, I would like to know 2 things. One would be the static type of S. And S is over here. And also, the second column, what's the dynamic type of S? Okay, I want to know about static type. I want to know about dynamic type. All right. If you are given this question here in the exam, it should be a very straightforward answer for the first column, for the static type. Because as we said before, static type never changes, right? So you can do right away to say, doesn't matter the timing, the static type for S, once declared to be a student, never changes, stay the same, okay? So I'm just going to make this column here just students. It's going to stay the same because it's been declared to be a student, never change. Okay, are we okay with this column here? All right, just remember, you got to be very confident when you're asked a question. Whenever you do code tracing about inheritance like this, you only change the dynamic type, not static type. All right, column number 2. Okay, for timing number 1, it's right before the variable assignment occurs. So at the moment, S is pointing to null. So no dynamic type, basically, which is okay. All right, I'll just put null. What about number 2? Timing number 2. Oh, by the way, when last Thursday, we talked about why S is assigned to RS versus S is assigned to NRS. They're both valid, right? That's the part I assume you know. And if we execute this assignment here, so now S is going to point to wherever RS is pointing to, which will be something like this. S, rather than pointing to here, is going to point to wherever RS is pointing to. Dynamically, S has changed its dynamic type from null into resident students, right? So number 2 here should be RS. All right. And after this, we try to call S.get tuition. As I said before, we got 3 different versions of get tuition. We got either the one as student class, we got the one using premium rates in this class, or we got the one using discount rate in this class over here. Dynamic binding, here comes. It's going to tell you that the version of the method that's going to be called depends on the dynamic type of the context objects. Because as right now, dynamically, it's a resident student's objects, so the get tuition is going to correspond to the one in resident student class, which is the dynamic type. Okay? So here, get tuition, we know that as at this point here, dynamic type is resident students. So that means we're going to invoke the resident students version. That one there is going to use the premium rates attributes, which will be something like you're going to sum up the base amount, which will be 100, and then multiply by 1.25. Right? Straightforward. Any question so far? This one tells you, whenever I ask you about what's going to be S.get tuition going to call, you can only answer the question properly if you know what the dynamic type is, meaning that you got to do some tracing. All right, let's move on. When we move on to number 3, right before we execute this assignment here, we haven't done anything just yet. So the dynamic type remains to be RS, which is good. And then we do another variable assignment here. S is now going to point to wherever NRS is pointing to. NRS is pointing to this object here. So that means S, rather than pointing to here, is now going to point to here. So we effectively change the dynamic type of S from resident students into non-resident students. So at number 4 over here, the new dynamic type will be NRS. So once you have traced the new dynamic type, when you get to the new method call, the same method call basically, when you get to this particular method call, because at this point here, S dynamic type has become NRS. That tells you when I call S dot get tuition, is going to follow the link and see that, okay, dynamic type is non-resident students. So I'm going to use the version that's declared over here using discount rate, which will be 100 times 0.75, right? All right, so this one here is going to invoke the non-resident students version. So when you study for this page over here, this is what you should notice. Number 1, know very well at the different timings over here how the static type is going to remain just the same, and how the dynamic type of the variable is going to change as you try to execute different variable assignments. That's number 1. Number 2, whenever you're trying to decide which version of the method that's being called, you have to look at the dynamic type for the context objects, which can be, in this case, resident students. In this case, it's non-resident students. So that's why they're calling different versions. This is dynamic binding. Okay? Any question? Yes? Sorry, I'm a little bit lost. Can you say that again, please?
So there's a function in the child and the parent.
Yes.
They both have the same name, but
Yeah.
the S is assigned to a dynamic type.
Mm-hmm.
So if we call the function name on the S,
Mm-hmm.
which one is going to be called?
Yeah, so that's exactly what we have just tried to illustrate. Okay, let me say it again. This might be where the confusion might come from. So here you see S was declared to be students. So you might be tempted to think, whenever I call s.getTuition, of course I should really go to the student version. Not the case. Dynamic binding tells you that whenever you have a method call over here, the version of the method that's being called does not depend on the static type. Static type is only for compilation. Once you pass the compilation, everything else will be about the runtime. When you want to trace the runtime behavior, you have to look at the dynamic type. So now in this case, after this reassignments, we know that S will be dynamically point to some resident students objects, not students. So in that way, we're going to call the version of getTuition in this class only. On the other hand, after executing this reassignments, S is now going to point to this particular object dynamically is non-resident students with the discount rate. So if we try to make the same method call, which version are we going to call? It's going to correspond to the dynamic type here, which is non-resident students. So in both cases, we are not really invoking the parent version explicitly, not really. Okay? Does that kind of answer your question? Good. Yeah. 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 Uh-huh. Yep. Exactly. So what Alireza has just said here is also right, which I didn't really include over here. For example, let me say over here, let's say star. Star over here. So at the star here, if I say s dot, let's say set premium rates to be one, let's say 2.65. Let's say, okay. We knew that at this point over here, S was pointing to some resident student object, which should support premium rates. However, writing this method call here is not going to compile. Because we talk about compilation, you should look at the static type for S, which is the students. Student itself does not declare set premium rates. Student is actually over here, for which you can only call these attributes and methods, which doesn't include premium rates. So that's why here it does not compile. Doesn't matter what the dynamic type is. So we're talking about two very different things. Whenever you talk about compilation, look at static type. And whenever you talk about runtime, it will be dynamic type. If you have to memorize something, I would say these short lines are something you want to remember. Okay? Does that answer your question? Yeah, but for that one there, if you do some typecasting, you can make it work, but that'll be for Thursday. Yeah. Alrighty, so that's about dynamic binding. If you guys have no follow-up, I would suggest we move on. All right, so very quickly about inheritance hierarchy. So far we spoke about student and two subclasses. In general, you may have like a multi-layer. You can think about layer number 1, number 2, and number 3. Okay? So in this course, we don't really talk about what a tree is. So I would suggest let's not define what a tree is. Just see very naturally, whenever you got extends, let's say this class extends this class over here, you can easily have a structure like this. And to really see systematically how this structure should be understood, that will be for another course, 2101. Now for this course, just understand the example that we spoke about in the class. That will be enough. Let's say under students, we got either domestic or foreign. Under domestic, we got either resident or non-resident, and etc. Right? We got multiple classes over here. It's definitely possible. So what I want you guys to think about is a reflection. We spoke about two designs without the inheritance and one design with the inheritance. For design number 1, how would you use that design to implement this hierarchy? The essence for design number 1 is use the integer kind attributes. And now if you want to use that for this hierarchy here, what would you do? You have to somehow say, maybe this is number 1, 2, 3, 4, 5, 6, and 7. Number 1. Number 2, for every method, you will have to say something like if the kind is equal to 1. I'm going to do something all the way to else if the kind maybe is equal to 7. In that way, I'm going to do something else, right? You got to do this kind of a distinction between the different kinds in every method. That's what you got to do. That's a consequence of choosing design number 1. What about design number 2? Design number 2, if you recall, would be creating a separate class for everything in the hierarchy. In that way, you will need one class here, one class here, one class here, every class. And you're going to have, number 1, lots of duplicates, for sure. And number 2, duplicate is really the problem. Okay, that's something you want to think about. Design number 2, you will simply get lots of duplicates. And also, all the classes, they are separate classes. There's no inheritance. In which case, you will just need to declare so many arrays like what we saw in the beginning of today's lecture, right? So how many arrays do we need in this case? 1, 2, 3, 4, 5, 6, 7. One array for each kind over here. And the design number 3 will be the inheritance case. In that way, you just got to think about in the top class, what common attributes should I really declare over here so that it will be inherited to all the subclasses over here. That will be the kind of issue you want to worry about, which is something you are thinking about for lab number 4. What should you declare in the subclass and what should you declare in the parent class, right? Yeah, do think about these because these are useful, actually, scenario to really kind of simulate, to see which one you should really choose. Of course, inheritance design should be the ultimate one to choose, but at the same time, you should know why the other two are not as ideal. So this will be another class hierarchy that we're going to use as a running example, okay, for the subsequent lectures. And the same reflection question for you. I'm going to leave that to you. But let's now go over this hierarchy a little bit more, okay? And then we're going to do some exercises. So it's more like a hierarchy for smartphone, okay? The models over here are pretty old, but you will see the idea, right? Let's not be too picky about the model names. So we got smartphone. That'll be the top level. And each smartphone, we expect a minimum functionality. Each smartphone should be able to dial and surf the web. Okay? And under the smartphone, we got 2 branches. We got branch number 1 and branch number 2. Branch number 1 is iOS phone. Branch number 2 will be Android. Under iOS, every iOS phone is going to override the surf web by using Safari, let's say. And then for every iOS, it's also going to add a new method, new functionality, let's say FaceTime, only specific to iOS. Similarly, for Android, you're going to override the surf web that's inherited from here by using, let's say, Firefox, a different way of overriding. And then you can add a new method there called Skype, all right, as opposed to FaceTime. If you go lower in the hierarchy, let's say you either got this phone here or this phone over here. And specifically for iPhone 13 Pro, you got another unique new method, Quick Take, for example. Okay? Under Android, you got either Huawei or Samsung. For every Samsung phone, you got a new method called Side Sync. And that means this subclass and this subclass here, both of them should really support Side Sync. Let's say for Huawei, you got these both of these models here. And for this model specifically, you got a new method here called Zoomage. Right? So this will be some kind of like a hierarchy. Usually you will have to come up from scratch in 3311 software design course. But for this course, you will typically be given this hierarchy to work with. All right? All right, any question so far just about the hierarchy? And we should really be able to somehow determine, let's say, given any arbitrary class in the hierarchy, what will be its expectation? That's something we're going to figure out together in a moment. Okay? But I just want to first introduce you to the hierarchy. Okay, good. Let's now go over some slides, and then we'll get back to this example very soon. All right, so we finished discussing the dynamic binding and the 2 hierarchies here, especially for the smartphone hierarchy here. Let's go over some slides. And the first two bullet points just review the idea about what a type is. So a type, in the case of reference type, is going to be a class. And a class over here may refer to anywhere in the hierarchy. So when I say a type could be smartphone, a type could be Samsung, because they exist in different places in the hierarchy, the way you kind of work with the variable of that particular type is going to be different. Right? That's why we're going to talk about how things might occur. Okay, just remember that. And then, so let's talk about inheritance hierarchy. Implicitly, the very top of the hierarchy should be objects. So if you remember back in the equals lecture, I said every class somehow is a subclass of the object class implicitly. However, I would say I'm just mentioning that over here so that you don't forget. But typically, when we talk about the hierarchy for our discussion, for example, this one here, you can imagine that the object class should be even higher. And then every class somehow inherits from there. But we don't really do that diagram. It will be too confusing. Just remember, object class is always there implicitly. But we don't really draw that. Okay? All right, so this is the thing. Each extends declaration, if you say class A extends class B, is going to correspond to some upward arrow. Okay, what do I mean? Let's now take a look at some example here. Okay, for now, just forget about this just for now. Let's say I got some class X over here. If I say X extends Y, is going to correspond to this arrow here. Extends Y. And then I can have maybe another class Z over here, which also extends X. So whenever you see the extends keyword, that really means the class extends another class. Okay? So I would say X directly extends Y. Z directly extends X. However, I wouldn't say Z directly extends Y, because you can see there are two extents apart. Right? So in this case, how would I refer to it? Here, I will only say Z indirectly extends X. Indirectly, not directly. All right, let's go back to the slides. Okay, it's transitive. Yeah, exactly what I just said. So you can see that Z extends X, X extends Y. So indirectly, Z extends Y, indirectly. All right. Now, let's now generalize the term about child and parents. I'm going to generalize child into descendants and parents into ancestor. That's going to help us to define our rules for variable assignments and other things. Pretty straightforward definition, but let's be careful here. Let's start with ancestor. If I have a class called A, how do I define, how do I derive the ancestor classes for A? It's going to be, number one, A itself, plus all the classes that A either directly or indirectly extends. How do I see that? Over here. So you can see here, I got A here, itself should be the ancestor. A should be included. And then A directly extends this class over here. A also indirectly extends this class over here, and so on. So you can think about we're basically following this up arrow here all the way up to the top of the hierarchy. You can see that, right? That's how we do. So we're going to go all the way to the top. And the way go there is by following the arrow over here, all the way. So the ones I mark as green is called ancestors for A. So ancestors of A. And what can we observe about the ancestor of A? Several things. Well, two things, basically. You can see since A extends this class over here, that means every attributes and methods that's declared in this class will be inherited to A. Because every attributes and methods that's inherited to, let me say it again. for this class over here, every attributes and methods is going to be inherited to here, which will be in turn inherited to here as well. So we say that A accumulates all the attributes and methods along the ancestor. All right, let's write it down. A accumulates the attributes and methods from its ancestors. And when we talk about attributes and methods, we also said it's the expectation. So whatever expectation that we have for all the ancestor classes, we can expect that all of them are accumulated into A. All right? And number 2, that's just the first one, right? Accumulates, that's a keyword. And number 2, you can think about the expectation for A should be larger than or equal to the expectation of any ancestor. Because potentially A can really just add new attributes and methods here, which will just make it more expectation compared with all its ancestor. Whatever the ancestor has, A should have it because of inheritance. But A can also add something additional as well. So that's why we say larger than or equal to. Does it make sense so far about ancestor? And symmetrically, we should talk about descendants. Descendants simply means all the classes that either directly or indirectly extends A. So the opposite direction. All right, let's now take a look. But you should always remember, whenever you talk about descendants, you should also include A itself. And these two classes directly extends A. So they should be part of the descendants. And basically all the classes underneath should also be included. So everything here. So whatever I highlighted in pink, so these are the descendants classes for A. And what can we say about them? So we talk about descendants. Descendants of A. Number 1, whatever expectation we have in A is going to be accumulated down to all the descendants. The expectation of A is inherited to all descendants. That's number 1. And number 2, what about the expectation? If I compare, for example, the expectation of A with maybe some descendants over here, which one should have a larger expectation? Should be here. Because not only that this one here is going to inherit the expectation from A and others, but also it may have some new attributes and methods, so more expectation. So the expectation of A should be less than or equal to the expectation of any descendants. Right, so you really want to watch out for these two here. Number 1 here, when you compare the expectation of A with its ancestor, and number 2, when you compare the expectation of A and its descendants. So these are the two things. This diagram here, I agree, it's a little bit abstract here, but that's the best way to generalize the issue here. And we're going to do one example together. Any question about this one here? And one more thing to say. As you can see, the lower you're getting to, for example, if I choose the class over here and a class over here, this class is definitely much higher than this class over here. That tells us the expectation for this particular class over here should be larger than this class over here. The intuition is this class is going to inherit all the expectation from here, number 1. Number two, it may add more expectation to it. Okay, that's the intuition you want to remember. All right, if no question here, let's do one example. Hopefully that will feel a little bit better. Let's now talk about the smartphone example here. Okay, so now I'm talking about three classes. Smartphone here, Galaxy S21 here, and also iPhone 13 Pro over here. Those three classes. For each one of them, let's figure out ancestor, descendants, and what would be the expectation if we use that class as a declared type of some reference variable. All right, so these are the three things we want to figure out. All right, and then I'm going to make some observation. Why don't we start with smartphone? What will be the ancestor for smartphone? When you say no, like a no ancestor? Itself, yes, good. Just don't forget, just itself. And there's no other extents further, right? It will be smartphone, I'll say SP. What about descendants? What will be the descendants for smartphone? Every class, exactly, including itself, right? It's going to be itself, the classes directly extends from it, and all the other classes extend, indirectly extending it, right? So all classes. Okay, let's go for the other extreme. Galaxy S21. What would be the ancestors? Would you say all classes? Ah, you guys are good. Okay, I'm glad you didn't say that. Good. What should that be? How many ancestors are there for Galaxy S21? How many? 3 or 4? Ah, good. Itself, here, here, and here, right? Very nice. So you basically follow the arrow over here, follow the arrow over here, and follow the arrow here. So you got 1, 2, 3, 4. All right. So I'm going to write it down. Ancestor will be Galaxy S21, and also Samsung over here, Android, and also smartphone ancestor. What about descendants? Itself. Very good. Galaxy S21. Very nice. We'll talk about expectation in a moment. Okay. What about the ancestor for, let's say, iPhone 13 Pro? Right. This one's easy. Let me tell you the answer right away. So for the descendants, will just be itself. iPhone 13 Pro. Descendants will be follow the arrow. 1, 2, and 3. iPhone 13 Pro. Also iOS, and then smartphone. One thing I want to mention right away, okay? If you look at these two classes, somehow they are relevant. To see how relevant they are, you want to look at their so-called common ancestor. Common ancestor. Based on what we have seen over here, you can see if you look at the ancestor between these two, I can see here is here, right? Sorry. This one is here. This one is here. The only common ancestor you have is a smartphone, right? I'm going to highlight it. This one here and this one here. This is what we call the common ancestor. But if you look at the diagram, take a look. This will be the ancestor. This will be the ancestor. The only thing they share or converge in common will be smartphone, common ancestor. All right. On the other hand, how many common ancestors do you have for these two classes? 2. Because if you go up here, you can see now they converge. Common ancestor number 1, common ancestor number 2. All right. That's something just to note. All right. Now that we know about ancestor and descendants, let's figure out the expectation. All right. Let's start with something simple. What will be the expectation for smartphone? Only two. Whatever you declare here, dial and surf web. Dial and surf web. That's great. And what about iPhone 13 Pro? What will be its expectation? The idea would be you have to figure out along its ancestors over here, you should really accumulate all the methods and attributes from there. All right? So would you like to say that, please? Mm-hmm. Awesome. Good. I'm going to write it down. And another way for you to think about it, you can go backwards. You can start from the current class over here. The new method I have is quick take. So I can put quick take here right away. The quick take. And then if I go up here, I got surf web, I got FaceTime. I got surf web, I got FaceTime. And if I go up one level here, I got just dial left, right? Just make sure you don't miss anything. Okay, that's the expectation. Similarly, this one here, I'm just gonna do it. So for Galaxy S21, you can see there's no new method here, so skip. Here we got side sync. Side sync. And then we got surf web. And then we got Skype. And then we got dial. All right. Hopefully everything makes sense. And one thing to say. If you compare smartphone and iPhone 13 Pro, for example, smartphone and, sorry, let me say it again. Smartphone and iPhone 13 Pro. You can see iPhone 13 Pro is much lower in the hierarchy. So if you look at the expectation, we got way more. Compare this expectation here and this expectation here. We definitely have the dial and surf web in both of them, but you also got two additional expectation, right, for the lower class in hierarchy. All right, that's number one you want to remember. Number two, we talk about these two classes, they actually share some common ancestor, which is smartphone. That's why when you try to look at their sets of expectation, the only thing they will intersect will be dial and surf web. Okay? So you got dial and also surf web. So these two common expectations between these two classes are a result from their common ancestor, which is over here. Okay? So there are quite a bit of a story that you can see from this diagram here, right? All right, any question here? All right, let me write down one more thing over here. You can think about this part here, surf web, dial, and the surf web and dial over here. So that's the expectation of the common ancestor. All right, good. Any follow-up about this exercise here? Once we know about these terms, we're gonna make some rule. Talk about some rule, not to make up some rule. Okay, let's now go over some slides and then I'll talk about it. Okay. If you go back to the slides and the next one here, the lower a class is, the more expectation it has because it accumulates all the expectation from its ancestor, right? That's something we just spoke about in the earlier pages. So descending class will definitely inherit all the expectation from its ancestor classes, that's for sure. And it may have also additional attributes and methods like additional expectation. And let's now talk about some consequences from this. And then we're going to introduce a rule. Okay. So whenever, let's read it first, and then I'll try to visualize it. When being used as a context objects, instances of a class of descending classes have a wider range of expected usages. What do I mean? What I mean is this. So that when you actually read the bullet points from the study notes, you can also try to look at the visualization. Right? So if I have, for example, let's say I got some context object number 1. Okay, and also I got some context object number 2. What can I call after this will be depending on its expectation. So this part here will be expectation of context object 1's static type. And what I can put after the dot over here, it would be the expectation of context object 2's static type. So for example, let's say earlier here, if I say type number 1, context object 1, something here, and type number 2, context object 2. Right? You can see for context object 1, it has a static type T1. For context object 2, it has a static type T2. Right? If somehow we have an inheritance hierarchy, let's say, for example, if I got T1 over here and I got T2 over here, in this case, T2 is a descendant class of T1. We're just using our term earlier. If I know that, so that would mean context object 2 will have more methods and attributes that can be called over here because it's lower in the hierarchy. Okay? That's really what that bullet point is trying to say. So there should be a wider range of expectation, which means attributes or methods that are callable. Because T2 is a descending class. Of T1. Of course, you can easily say maybe T2 is resident students, T1 is students. In which case, if you try to say a resident students object dot something, the methods and attribute you can call over here to make it compilable is way more than students, right? For example, premium rate and set premium rate. All right, that's the first bullet point. The second one there is trickier, which we're also gonna talk about before I see the example. The second bullet point, again, let's read it. Given a reference variable, and we know that a reference variable simply stores the address of some objects, we may substitute this reference variable or simply reassign it. I'll visualize. We can substitute this object here by any of its descending classes. There's a very critical rule that we're going to learn today. All right. How do we see this one here? Okay, let me switch, and then we'll talk about it. Okay, let me have another new page here. Okay, here. Let's now again talk about different variables. Let's say we got type number 1, variable 1, equals something. Also, we got type number 2, variable 2, equals something. Up to this point, we know that V1 is pointing to something. And also V2 is also pointing to some objects. Agree? Okay, we're not worried about dynamic type. We're only worried about static type. Okay? After these, if I say V1 is assigned to V2. And let's now study this variable assignment here. So here, of course, the way we interpret from before is you're going to copy the address of V2 into V1. That's definitely okay. It's still valid. But let's now try to interpret this variable assignments in a slightly different way that's going to help us understand the inheritance rule. So here we say that we substitute V1 by V2. Okay, that's the new interpretation. What does that mean? Let's say this. If we allowed this variable assignment to occur, that would correspond to V1 rather than pointing to over here. It's just going to point to the same object here that V2 is pointing to. What does that mean? That means if, let's say, in maybe in here, if we were able to say v1.x, let's say, before the variable assignment here, before that, v1 is pointing to this object. So when you say v1.x, you're basically using the x attributes from this object here. But after this variable assignment is executed, when you say v1.x again, dynamic type is now going to point to this object here. In that way, when you say v1.x, you're basically using the x in this object here. So that's why we say that after this variable assignment, you're basically substituting the objects that's being pointed to by v2 for v1. So v1 is now going to refer to it for all the subsequent use. Okay, that's what substitute really means. All right. You can also refer to the slide later. That also tells you what substitute really means. And how do we consider a substitution being valid? Okay. So we try to substitute here, and we say that this substitution will be valid if, all right, in order for that to be valid, you want to look at the static type for v2, which is t2. You also want to look at the static type for v1, which is t1. You want to look at these two types, basically. All right, that's now annotated. So for v2 over here, it has the static type t2. For v1 over here, it has the static type t1. All right, so this assignment here should only be allowed if this t2 over here can fulfill the expectation of t1. All right, I'll write it down. Valid if v2's static type, which is t2, can fulfill the expectation of v1's static type t1. It's symbolic, but I'll give you an example after this rule. I want to talk about the general rule first. Okay, that's number one. And when you say the v2's static type can fulfill the expectation, that really tells you that v2 should be lower in the hierarchy in the inheritance. Okay? That's a consequence. v2's static type should be a descendant of v1's static type. So these are the two things you want to know. Okay, recap, and then we'll see some example. Whenever you got any reference variable assignment, especially somehow these two have their static type somehow related by inheritance. How do you know whether this variable assignment should be valid? You basically want to make sure the static type on the right-hand side should be able to fulfill the expectation of the static type on the left-hand side. And the consequence is we want to make sure this static type over here should be a subclass or descendant class of this class over here. Because we know that descendant class is guaranteed to have more expectation or the same compared with its ancestor class. Okay? So for that to be valid, you can think about if you got some inheritance hierarchy over here, right? So let's say, for example, T1 might be over here, and T2 is simply just somewhere here, for example, right? T2. So T2 is actually lower, which can make sure it can satisfy the expectation of T1, right? That's also the expectation topic that we spoke about earlier. Of course, we're going to need example to make this more concrete. Any question here? All right. Well, this will be something you may not need for tomorrow, but you will need that very, very critically for exam. Right? So that's why we need to spend time on the inheritance, but at the same time, you want to make sure, try to catch up with all the gap before each lecture, because things build up very quickly. All right? That's my very honest advice. Okay. All right, let's now do a little bit more, one more example, and then we take a short break. Okay. Let's do example right away to verify this rule. let's take a look at this. Let's say we got SP1, static type is smartphone over here. Smartphone is over here. And also we got SP2, which has the static type iPhone 13 Pro, which is over here. And we also got SP3, static type is Samsung over here. All right, we got 3 classes. Let's play with them. I want to know if I got some variable assignments over here. And the left-hand side is SP1, which is already known to be of static type smartphone. I want to know what can I put on the right-hand side over here so that the variable assignment is going to compile. According to the rule, this is valid only if the static type for the right-hand side can fulfill the expectation for the static type of the left-hand side. In this case, it is smartphone. So what can satisfy the smartphone expectation? All its descendants. What are the descendants? Every class over here in the hierarchy. All right? So let me now write this one down over here. Number one, if I say, let's only play with these 3 variables and think about different combination. If I say SP1 is assigned to SP2, and also SP1 is assigned to SP3. So both of them should be compilable. Both of them are okay. For example, for this one here, SP2 has a static type iPhone 13 Pro. Can it fulfill the expectation of the static type for SP1, which is smartphone here? Of course it can, because it's a descendant class. Okay. And for the very first one, I can write it down here. This will compile because SP2's static type, which is iPhone 13 Pro, can fulfill the expectation of SP1, which is the left-hand side, static type, which is smartphone. Right? You will compile, number one, you should know, and number two, you should know how to justify it. That's the result, and this will be the justification. All right? So that's the first set of example. When you got SP1 on the left-hand side, you want to think about what I put on the right-hand side can satisfy its expectation. All right, number two. Let's do one more. So for number two, if I put SP2 on the left-hand side, can I put, for example, SP1 and also SP3? All right. Now, we're going to judge by the same reasoning. You ask yourself the same question here. In order for this variable assignment to be valid, the static type for SP1, which is smartphone here, must be able to fulfill the expectation for the static type of SP2, which is iPhone 13 Pro. Can smartphone fulfill the expectation for iPhone 13 Pro in general? Not really, because smartphone only got dial and surf web, whereas for iPhone 13 Pro, it is expecting FaceTime and also QuickTake. So it's not good. So it doesn't compile. So for this one here, it's going to fail to compile. Because the static type of SP1 cannot fulfill the expectation of the static type of SP2. All right, similar reasoning. So if you put some ancestor class on the right-hand side and put some descendant class on the left-hand side, it's not going to compile. All right? All right, any question here? Okay, I'll take one by one. Go ahead first.
If you had an ancestor class on the right
Mm-hmm.
and a descendant on the left, and the only difference was an overridden method, could you assign it?
You cannot still. So the rule goes, okay, very good question here. Let's say, okay, I'm glad you asked this question here. I'm going to put it here. Let's say I got class parents. I'll make it very P for parents. I got another class here called C for child. Let's say we only got attribute I. Okay? Let's say for child class C, I don't have any additional attributes or method. Let's say no, which is completely legitimate. Now, your question was basically about this. If I say parents, let's say obj parents, something. I got child, obj child. Can I actually, of course, I know that objp assigned to objc. This one is good, no question. Okay? What about if I say objc is assigned to objp? First of all, short answer is it still doesn't work. It simply doesn't work because of the following. The expectation of the static type of objp, which is a parent class here, in general, cannot fulfill the expectation for the static type for the left-hand side, which is a child class, because at the moment, it is right. There is no additional expectation we have in the child class C. But it cannot disallow the possibility, let's say 2 years later or 2 months later, I may decide to add this class some new attributes, in which case, this will not compile anymore. So that's why the compiler will always check to see whether you're assigning parents, like ancestor, to child. If you're doing that, it just wouldn't compile. Even if, at the moment, there's no difference in terms of the attributes. Doesn't matter. It's a rule. Follow up. It's the same. So the way compiler checks will just to see, doesn't matter what the contents for the two classes. They only look at if the class is a descendant or if the class is ancestor. That will be it. Oh, that one specifically? Okay, something similar. So here, let's say this guy here is going to give you a compilation error. You will simply say something like objp is declared to be P. P is not a subclass of C. It's going to be the error message. Although it's not exactly accurate, because in general, in this way, yes, we talk about parent and child. But in a multi-layer hierarchy, it's not really just about parent and child, it's about ancestor and descendants. But you will see the idea from Eclipse. Yeah, in Eclipse, they got very simple error message there for you about what I just wrote over there. But the reasoning behind is way more complicated. That's why we're teaching it to you in the class. All right, guys, any question? Yes, go ahead. OBJC, no, actually, so you just cannot do this variable assignment. You cannot do it because the static type here cannot fulfill this static type here in general. That's why you cannot do it. There will be no circumstances you can actually make this compile. Unless you do some casting, but that's another story. Okay, so let's now move on. Okay, there's something about expectation which I can do very quickly. So guys, how about this? Why don't we go on for another 3 or 4 minutes, and then we'll take attendance and we are done. How about that? Okay. I would suggest we do one more exercises over here, and then before Thursday, I would suggest the following. Just one page for you to read. So before Thursday, please read this particular page over here. Substitution, we talk about it, right? Just about variable reassignments. And page 44, slide 44. So it got 3 different rules about substitution, and we're going to discuss each one of them very quickly on Thursday. But before that, I would suggest try to read over the bullet point. That's something you got to do anyway for the exam. Why not now? Okay? Before Thursday, please read this page here. And I'm going to spend about 2 or 3 minutes doing the stuff on the iPad, and then we'll take attendance, and then we're done. Okay? Just bear with me. Almost done. All right, so let me try to do maybe exercise here very quickly about expectation. As soon as you declare the static type, let's say student here, you will know what the expectation is. So now if I say Jim dot, I want to know what's really exactly a question mark over here. So that one there, I'm just going to make it a little bit symbolic. So this one question mark, it could be the name, can be courses, can be NOC, can be the register, or it can be get tuition, right? All these. That's like the table we should have filled out last time. What about if the static type is actually smartphone? Similar, if I say my phone, static type is smartphone. What can I put over here? It's going to be just dial and surf web, nothing else. Okay, that's easy. Okay, let's make it slightly lower in the hierarchy and compare. Now you can see we got Jim and also Alan. One has the static type student, one has the static type NRS, right? Non-resident student. Apparently, this static type is lower in the hierarchy. So we know right away, potentially, the expectation on Alan could be wider. Okay? So for this one here, I'm just going to write something here, and you can just kind of convince you whether that makes sense. So Alan here is going to be, not only that, it's going to be the discount rates and set discount rate, but also it's going to be the name, courses, number of courses, register, and get tuition, everything, right? And you can think about it's the expectation of students plus the discount rate and plus the set discount rate. Right, so these are the expectation. And that one apparently is actually more than the expectation for Jim, which only contains the expectation for students. Okay, final one. How do you compare the expectation for P1 and P2 over here? P1 was declared to be smartphone. P2 was declared to be Samsung over here. And the expectation for Samsung over here should be more, for sure. All right, so what would that be exactly? Well, that's also something we did earlier. What can I pass over here? It would be SciSync, Skype, Surf Web, and Dial. That one for sure is more than P1. P1 is a smartphone, which only got Dial and Surf Web, but it doesn't have the Skype and SciSync. All right, so that's simple exercises you can also try to do to convince yourself. All right, so before Thursday, please try to catch up with what I said today. It's very fundamental, and we're going to talk about some rules very quickly, and then we're going to talk about typecast. All right, let me stop the recording, and then let's take attendance.